Hello everyone, this is Sudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. Today I'm going to give a lecture on the subject of switchgear and protection. In this subject, we have few important topics to discuss. So the first one is the introductory part, that is the fundamentals, necessary functions of protective systems, normal, abnormal conditions, faults, different types of faults and their causes, use of current limiting reactors and their arrangement, and short circuit KVA calculation for symmetrical faults like this. Then in unit 3 there is some protective relays, and like overcurrent relays, there are also the directional relay, distance protection schemes, differential relay, and then finally in unit 4 there is some equipment protection like generator protection, transformer protection, protection of motors, protection of bus bars and transmission lines. So it's a very important subject for electrical engineer. This subject is basically designed for third year diploma electrical engineering students in the fifth semester. So the engineers need to know about the subject very much, because when they will become a professional engineer, they have to face different types of problem in electrical system. So they don't know that what are the different types of fault occurs in the problem, and what is the solution method, or what are the protection schemes of this type of fault. So it will be very difficult for them to deal with the systems. So for that reason, to developing the basic idea regarding the faults and protection, this subject is designed. So let me start the topic. So today's topic of discussion is current transformer, and you all know that the short form of current transformer is CT. Here the content is, I will talk about the firstly about the introduction, then about the instrument transformer, need of instrument transformers, applications of instrument transformer, then current transformer, part of current transformer, working of cities. Let's learn more about cities, then calculation of cities, application of current transformer, and safety of current transformer. So these will be today's topics, or you can say the contents of today's lecture. Now, here in this introduction part, transformer is a device you all know that transfers actually electric power from one circuit to another circuit, and it does so without change of frequency. Okay, this is basically the definition of the transformer. It accomplishes this by electromagnetic induction, and it is divided into core and shell type transformers. For instrument purpose, we use instrument transformers. So it is under the instrument transformer, you all know. So let me talk about the instrument transformers. These are special types of transformers used for the measurement of voltage, current, power, and energy. The special type of transformers. Okay, so for measurement purpose, we use the special type of transformers used for the measurement of voltage, current, power, and energy. As the name suggests, these transformers are used in conjunction with the relevant instruments such as the ammeters, voltmeters, wattmeters, and energy meters. So it's a very brief idea about the instrument transformer. Now the question is the need of instrument transformer. Why it is so useful? Why it is necessary? We have to learn that For the purpose of measurement of large current and high voltage in transformer, we use instrument transformer. So why we use instrument transformer? For the purpose of measurement of large currents and high voltage. Okay. So measurement of large current and high voltage in the transformer, we use the instrument transformer. Secondly, it also make it possible to measure it with low range voltmeters and low range ammeters. Okay, so it also make it possible to measure it with low range voltmeter and low range ammeter. With this, for this purpose, specially constructed accurate ratio instrument transformers are employed in conjunction with many measuring instruments. So they are basically of two types. One is current transformer and one is potential transformer. So these are the two types of instrument transformer you will find. So that's the need of instrument transformer. Now, application of instrument transformer. Let me talk about the application of instrument transformer. So instrument transformer would not be economical to have a ammeter to measure 600 amperes in a conductor directly, but we can have an ammeter range 0 to 5 amperes, which corresponds to 0 to 600 amperes. Then similarly, I can say for measuring voltage of 14,400 volts directly, it would not be economical. So we place 0 to 120 volts will be corresponds to 0 to 14,400 volts and economical. Now at the end, you know that the degree to which an instrument transformer produces current or voltage that is proportionate to the one to be monitored is to its accuracy. So this is that's actually the applications of instrument transformer. Now I'm moving to the specific topic, that is the current transformer, or today's main topic of discussion. So here the current transformers generally used to step down current, generally used to step down current in a very predictable fashion with respect to current and phase. Okay, so now the next one, the current or series transformer has a primary coil of one or more turns of thick wire connected in series with the line whose current is to be measured. So you have to remember this one. The current transformer has a primary coil of one or more turns of thick wire connected in series with the line whose current is measured to be. And then the current transformer, about the current transformer, I can tell you that the secondary consists of a large number of turns of fine wire and is connected across the ammeter terminal. So where it is connected across the ammeter terminal, this is the secondary terminal, this is the transformer, C1, C2, ground terminal, high voltage terminal. Okay, this is the inductor. Now let me move to the next part of the lecture, that is the parts of current transformers. Here, like any transformer, a current transformer has a primary winding, a core, and a secondary winding. Although some transformers, including current transformer, use an air core, in principle, the only difference between a current transformer and a voltage transformer normal type is that the former is fed with a constant current while the latter is fed with a constant voltage, where constant has the strict circuit theory meaning. And finally, typically current transformer consists of a silicon steel ring core wound with many turns of copper wire. So these are the parts of current transformers. Now, working of the current transformer, or you can say the how the current transformer works. The alternating current in the primary produces an alternating magnetic field in the core. So where it is producing primary in the primary alternating magnetic field in the core, which then induces an alternating current in the secondary. The primary circuit is largely unaffected by the insertion of the CT. Then accurate current transformers need close coupling between the primary and secondary to ensure that the secondary current is proportional to the primary current over a wide current range. So accurate current transformer need close coupling between the primary and secondary. Why? To ensure that the secondary current is proportional, secondary current is proportional to the primary current for the wide range. So this is actually the working of principle of the cities. Next, uh, you can say the current in the secondary is the current in the primary, assuming a single turn primary divided by the number of turns of the secondary. And then finally the conductor carrying the primary current then passed through the ring. The series primary therefore consists of a single turn. The primary winding may be a permanent part of the current transformer with a heavy copper bar to carry current through the core. So this is the calculations of cities. You all know about the calculation of cities. Look here. If the current transformer has primary to the secondary current ratio of 100:5, then it step up the voltage 20 times, whereas it step up the voltage 20 times, whereas it step down the current 1 by 20 of its actual value. Hence, if we know current ratio I1 by I2 of the transformer and the reading of the AC ammeter, the line current can be calculated. So here for an example, a 100:5 transformer is used in conjunction with a 5 ampere ammeter. If the latter reads 3.5 ammeter, find the line current. Solution, as we know that I1 by I2 equals to 100 by 5. Now primary online current equals to 3.5 divided into 100 by 5. That will be the current amount. The amount will be 70 ampere. So this way we can find the line current 70 amperes. Now the applications. So here this is the application part on the right hand side. The application of the current transformers. So try to understand it very carefully. Current transformers are used extensively for measuring current and monitoring the operation of the power grid. Okay, so current transformer can be mounted on the low voltage or high voltage leads of a power transformer. Sometimes a section of a bus bar can be removed to replace a current transformer. Look, this is a very important part of this lecture about no. Current transformer can be mounted on low voltage or high voltage leads of the power transformer. Sometimes a section of a bus bar can be removed to replace a current transformer. Okay, so how much it is important to install in the system? Look here. Often multiple CTs are installed as a stack for various uses. Multiple CTs are installed as a stack for various uses. What are the for an example? Protection devices and revenue metering may use separate CTs to provide isolation between metering and protection circuits. Okay, so these are the applications of current transformer, or you can say application of CTs. Now we need to take some safety of current transformer. So what are the safety? Look here. Regarding the safety issues, it is considered important as the secondary of the current transformer should not be disconnected from its burden while current is in the primary, as the secondary will attempt to continue driving current into an effective infinite impedance up to its insulation breakdown voltage and thus compromise operator safety. So the safety of current transformer is very much necessary because you can understand from here that it's considered important as the secondary of the current transformer should not be disconnected, okay, from its burden while current is in the primary, as the secondary will attempt to continue driving current into the effective infinite impedance up to its insulation breakdown voltage and thus compromise operator safety. So this is the reference I used to make this PowerPoint presentation, and several books is also there which helps me a lot. Now finally, thank you everyone. If any queries is there, please contact with me through my mail or WhatsApp number or phone. I will always be there to give you the answer. Thank you everyone. Thank you for watching the video.